Hello, this is Kamal with the Elastic team, continuing this series on features. This video covers the orientation feature group. You can see that I've loaded the same dataset for demonstration purposes. Let's select the mega huge orientation feature and visualize the results. You can see that two features get calculated here for this group, structure tensor and Hessian matrix of Gaussian. Unlike the previous features we've seen, which calculated a single value for each pixel in each channel, the features in this group calculate 3 for two-dimensional images and 6 for three-dimensional images. So this is a simple grayscale image with a single channel, but the structure tensor feature has 3 channels. Let's see why. The first channel is sensitive to horizontal lines and a little bit to diagonal lines. This corresponds to the product of the derivative in the vertical direction with itself. Similarly, the last channel is sensitive to vertical lines and a little bit to diagonal lines, because this is the product of the first derivative in the horizontal direction with itself. And finally, the middle channel is the product of the two derivatives in each direction, and it is sensitive to corners and diagonal lines. You can see that it differentiates between lines that slope up and lines that slope down. Also between top right and bottom left corners and top left and bottom right corners. Similarly, the Hessian matrix of Gaussian feature also detects horizontal, vertical, and diagonal lines and corners. In this case, it's computing the second derivative, here the second unmixed derivative in the vertical direction, the horizontal direction, and the mixed derivative. So just like we saw in the Laplacian of Gaussian feature, this characteristic double line appears on edges, dark on one side, bright on the other, and gray in homogeneous regions. Now you've seen what exactly gets calculated. Now let's see a dataset in which the orientation features can really make a difference in the accuracy of the classifier. The task here is to differentiate between circles with different orientations of lines. So we'd like to differentiate circles in each column from circles in other columns. I've created the appropriate labels and marked up some pixels already. Now if we only select color and edge features and start live prediction to visualize the results, it's not very good, because there's not enough information to differentiate between the orientations of the lines within each circle. But adding the orientation features really makes a big difference, and the results look very nice. So in this video you've seen what gets calculated for orientation features and when you might want to use them. That's it for this video. Thank you for listening.